Lecture 12, Integer Programming, Part 2, and the last part of this lecture. So in the previous part, we covered the hotel selection case, and now we are going to cover the class assignments in this part. Here we are talking about the SAR Academy, which is a private day school in New York, okay, in New York City. And every summer, SAR Academy should create class assignments for their elementary school students. So each grade includes 80 to 100 students, and we should divide into different classes, these 80 to 100 students, okay? We have constraints here, and the constraints are coming from the requests made by the parents, teachers, and also a school therapist, okay? So we have this kind of request like pair of students should or should not be placed together, and students to be placed in classes that better suit their unique or special academic needs. And also in case of conflict, the administration needed to prioritize their requests. Okay, so we have these kind of constraints here. Okay, so let's assume a simplified version of the problem by assuming 40 students and 2 classes. Okay, so here the parents are asked to send their preferences for class 1 or 2. So the basis for preferences on the parent side could be these issues like teaching style of the teachers, or the teachers that older siblings have had in the past, or the characteristics of each class. For example, one is called an inclusion class, so it could be better for students with academic needs. Okay, so the preference of the parents as well as the gender of students are collected in a table that we have in the next slide. Okay, so yeah, see here we have the 40 students here, 1 to 40, and we have the parent preference for class 1, parent preference for class 2, and male or female, the gender. Okay, so we have these data here. Okay, so here is our problem. We want to decide which students should be assigned to which classes, and also we want to satisfy the parents' preferences as many as possible. So in the table we have numbers 1 or 2. So the smaller number in the preference is the better one. That means 1 is the first priority and 2 is the second priority. So those numbers are the priorities. So because of that, our problem becomes a minimization problem, because when we minimize the priorities, that means we are trying to assign more with the first priority. Okay, and each student should be assigned exactly to one class, and also there should be exactly 20 students in each class. So these are our constraints, and also the objective that we want to have here. So based on these characteristics, we can build our model. Okay, so now let's formulate our problem in terms of an integer programming model. So here we can define the decision variables like x1 I and 0 or 1, and x2 I, again 0 or 1. Binary variables. So x1 I would be from 1 up to 40, the number of students, right? So that means we have 80 decision variables here, and x1 I would be, if it takes the value of 1, that means the student I is assigned to class 1. Okay, so based on this, our objective function would be minimizing, and I goes from 1 to 40. So let's say the P1 is the first priority of I'm not first, I mean the priority for class 1 for student I, okay? And this should be multiplied by x1i and then plus p2i times x2i, okay? So this would be our objective function. We want to minimize that, and the constants that we would have here, since we want to have at exactly 20 students at each class, so for class 1 we would have I going from 1 to 40, x1i should be equal to 20, okay? And same for the second class, so sum over I to 40 x to I should be exactly equal to 20. And since we want to assign each student to one class, then that means x1i plus x2i should be equal to 1, and this goes for all i's. That means here we have 40 constraints, okay? And so in total, as you see here, we have 42 constraints, okay? So this would be our optimization model, and we can solve this to obtain the optimal solution, okay? Okay, after solving the model, the optimal solution, for the solution, the optimal objective value is, I mean, Z star is 42, and 38 students were received their first choice. I mean, the first priority. So because of that, we can say the 2 students have received the second priority, and 38 students have received their first priority, okay? And so this is our solution. Now the management, I mean the school, decides to have a better balance of boy and girl ratio in both classes. So because of that, they want to add a constraint that limit the number of boys in each class to be no more than 12. Okay, so if you take a look at our table, we see that the first 23 students are boy and the rest are girls. So because of that, we can add these two constraints. So I going from 1 to 23, x1i, this should be less than or equal to 12. This is for class 1, and for class 2 again, 23x2i less than or equal to 12. Okay, so by these two new constraints, we can have a new optimal solution, and the number of boys in each class wouldn't be more than 12. Okay, so in this solution, we see 34 students are receiving their first priority. Previously, we had 38. Now we have more constraints. That means the solution wouldn't be better than the previous solution. So 34 students are receiving their first priority, and 6 students are receiving the second priority. Okay, so this would be the optimal solution of the new problem with new constraints. Okay, so now we can add more logical constraints to the model, like students 10 and 11 are twins, and based on the school policy, twins should be assigned to different class. So these two students, 10 and 11, cannot be in the same class. So having the binary decision variables and integer programming on binary variables, we can easily formulate these constraints. So we would see in our lecture session that how we want to formulate these constraints on, and also this constraint, students 4, 9, 15, 25, 30, and 36 are all from the same neighborhood. So the school would like to put at least 2 students from this neighborhood in each class. So yeah, I mean, we can apply these policies. Or for example, the school therapist is strongly recommending the students 20 and 21 are placed in the same class. Student 1 to class 2 and student 40 to class 2. So yeah, we can easily apply these recommendations as logical constraints in the model, and then we can resolve the model and obtain the optimal solution. Okay, so in this lecture we covered integer programming, and as you see how strong is the model by having the binary decision variables, and we can apply very very real situations in our model. Okay, so okay, we'll have these examples in R in the lecture sessions, and we'll see how can we implement them in R and obtain the optimal solution. We will have more discussions. Okay, thank you.